Ashi. Now this is the last task, task 5. Task 4, but it's numbered, task 5. And it says, about how big do you think the answer to this problem is? 54 times 24.
Can I do it?
Yes, you can do it. Do it in any way you want.
Yes, you can bring your snacks, sweetie.
Mm-hmm. So you multiplied 24 by 24.
Yeah.
Yes. And this says 54 by 24. It's okay. Could you get to 54? From this, could you get to 54?
Yeah.
If one of these could be 54 and one of those could stay the same, 24? Could you continue? Go further?
I need to do this a problem again, so I can't.
Oh, so you want to start all over? Okay. Mhm. So this is the answer.
Yeah.
So you thought about it like algorithm?
Mm-hmm.
Standard algorithm. Okay. Now, I was thinking that you could explain this to me in another way. You could solve this problem in another way. Okay, it's all right. Okay, now, what is the little one? Okay, let me think. All right. When you did this, what's this?
4,
Times?
4, 16. Put the 6 here and put the 1.
Okay, and what is this?
It's a 1, but I crossed it. I want to move. So
Okay, you crossed it out. Okay, and what'd you cross out the 1?
why?
Yes.
Oh, I crossed it out so I didn't get confused when I move on to the next number. Because I'm going to do 2 times 4, it's 8. And then when I do 2 times 7, I'd get confused and add the 0. It's crossed out.
Okay, and can you explain this multiplication?
Yeah, just when you move to another, like the next digit,
Mhm.
you add a 0, and then you finish multiplying.
Okay, then when you took out 1 from this, what is this in terms of place value? You know how we did there? Ones, tens, hundreds.
Yeah.
Like, what place value is this digit? 5.
1,
Ones? Why is that?
because it's not like, it's only 1 digit. If it's 2,
It's on the ones digit, but how do you read the digits?
it's 5,
No, how do you read the digits? 1 from
One.
left to right or from right to left?
from right to left.
From right to left. From right to left, do you mean the
So this
biggest
is-
or the smallest?
This is supposed to be, I think, 10, because this is
Oh,
ones.
okay, so it's not ones, it's tens.
Yeah,
Because why?
because it's on the 10th place.
Mm-hmm. Good job. Okay.
Good job.
Great. So far. Okay. Now, let's see here. What if you saw something like this? Let's say somebody else solved this problem, one of your classmates solved this problem this way. Try and to make sense and tell me what each of these numbers means. How did he find each of those products?
Oh, I know I hate it here.
What is it?
He did the same thing I did, but that's what they did.
You've done this before?
No.
Oh no? Okay, let's
You want me to tell you what they did?
Yeah, sure.
4 times 4, it's 16, but he's supposed to put the 6 here and the 1 on top of the 5.
Mm-hmm.
So he just put 16, and then when he moved, he said 4 times, he's supposed to add a 0 when he moves down. So he did that, and then he did 4 times 5 is 20. And then when he moved here, he put 2 times 4 is actually he added a 0 here. So 4 times 2, it's 8. And then when you add 2 zeros here, and then you do 2 times 5, it's 10, and then you get the answer.
Okay, so he added a 0 each time? What do you
Yeah.
mean he added a
Each
0
time you
each
go
time?
down, he added a 0. When he goes one more time, he
Mhm.
added 2.
Okay, he added a 0 each time. So, uh, what about making this recomposing a number? It's called. What about if you could like make this number into two smaller numbers?
Yeah, I think you can divide it by 2, and this is by 2. And
Yes,
Half.
great. But the way he multiplied this, let's do this again. Let's think about it again. How did he like? Let's go individually again with those numbers.
4 times 4 is 16.
Mm-hmm.
And then he did, he added a 0 because he moved down once. Every time you move once, you add a 0. When you move again, you add 2. He
You
added
move once, you add a 0.
and then
So
one to another.
you say when you move once, you add a 0. So is 0 meaning that 0 has no value? That's why we add a 0 to the ones?
No,
Does it
but
mean that 0 is not as important, or?
it is, but that's how it works. When you go down, you add a
Mhm.
0.
All right, good
One
job,
more.
Nashi. All right, okay. Now, I thought that you could have this blank piece of paper and you could write down 86 times 17.
Should
I
do
want
it
you
the
to
same
solve
way?
this problem. Yes.
Same way you
In
did?
standard algorithm or any other way. You
Should
could
I
think
do
of
it like this way?
If you want to
You
try that
could,
way,
you,
go
you
for
could
it.
try it that way too.
2. 7 times 8 is 56.
Mm-hmm.
60. Then you add a 0. 6. Since I moved down, I add 2 zeros.
How did you get 60?
Because 1 times 6 is 6. But 60 because I every time I move down, I add a 0.
Okay, you mean when you move this way?
No, I do this and then I get the answer. And then I did this times this, I get the answer. When I move to the next digit here,
Oh,
I add a
okay.
0 here.
All right, sure. Go ahead and
And then
complete it.
this times 6, I did it, and this is 8.
And so you added a 0 there because. Can you explain to me the 800?
Yeah, since I moved 2, like I did it here,
Uh-huh.
this times this. When I moved here, I did 2 digits, but when that I multiplied it by that one, I add 2.
Okay. Then give me the answer and continue and give me the final answer of that.
16.
Okay, great job, Nashi. Okay, now I want you on the same piece of paper, I want you to do the same problem in a standard algorithm.
That means the way you normally do it, like in class.
Oh,
Yes. Okay. Okay, now take a look at this. Okay, let me find the paper. Okay, so now this is the problem that you did, 54 times 24, standard algorithm. And this is the other way, partial product. And you see this. Take a look at the answers here.
yeah, oh, different.
Different, okay. Now, let's take a look at your solutions, your answers from solving the problems in both different ways. Now, I want you to look at the two numbers. And you see that they're different, right? Now, first of all, do you think that two answers of the same problems should be different?
No. They should
No?
be the
Why not?
same. I think I messed up, but they should be the same.
It should be the same.
Because
Okay.
they're the same problem and you're just multiplying.
So where did you think you messed up?
I think I messed up somewhere.
Oh, somewhere there. Okay. And because take a look at the answers. This and this. Take a look at the difference between the answers. Take a look at the place value.
This is on the thousands and this is still on the hundreds.
Good job. Yeah, great response. Okay, now I want you to take a look at these digits, this number of digits, this and this, and I want you to think about what you could have possibly done wrong, because I know you haven't used this method in your class before, and you know, I just want you to like take a look and see why, like, give me an answer about the 800 or the 160.
I must here. This part's right, but here it's wrong.
Yeah, why
I
is this
should've
part
added-
right?
Because when you go on, when I did this times 6, it's 42. It's right. And then when I did
What's 42?
7 times 6 is 42.
Yes.
7 times 8, it's 56.
Okay.
And then when I move on, I was supposed to add a 0 once, but I added again here and here.
Yes.
So I
Well,
should really-
look here. Okay, where was the answer? Okay. You remember how you did this?
Yeah.
Remember how you did this? What is it?
Just, are we almost good or?
Oh, just 5 more seconds. Okay. Take a look at this. 6 times 7.
42. The 2
Okay.
here.
Take a look here.
6 times. Oh, put the 42 here.
Okay. So you did this. But take a look at this. If you go further, 7 times
8.
is...
56, but that's 460.
But here, remember how here we were doing this thing with the zeros? But were they really zeros? Like, you know, if you think about it, or was it because maybe this number was taking like something else? Was like, let's say, like, you know, we could have 24 equal to 21 plus 3, 54 to 50 plus 4.
Yeah.
Maybe, maybe we could like take those two and multiply with one another separately, right? And there's other ways we could see 24, right? In
12.
addition.
Yeah,
12 plus.
12.
Good job, yeah.
Or here we can do like 27 plus 27.
Great job. Okay. Okay. That's awesome.